Alligation. What we are doing today are alligation questions. So you'll see that they're similar to what we did in the last part. So again, one of the questions will come from there. So let's just go on. So let's work together on the first one. So I'm going to help you set this up because this is a visual thing, and I don't want you to solve these with C's and Q's. Even though you can solve some of these questions with what we learned and what we did last week, I want you to do it differently. Now, on the exam, going back to the quiz and on the exam, will I tell you to solve by alligation? No, because you would lie to me anyways. You will do it however you want to do it because you're just turning in the final answer. So as long as you get the correct answer, it does not matter to me whether you do the algebraic methods with C's and Q's or whether you do what we're doing today with the alligation. But I want to strongly encourage you today to practice the alligation method. For some people, it is so different in setup in the terms of the way you can kind of visualize this that some people do really well with the alligation. So again, trying to do something, the same thing, but in a different way. So let's start with this. So the question for the first one we're going to start with says, how many grams of vanishing cream, which is a diluent, must be added to 60 grams of chromaton 10% to reduce its strength to 7%? Okay, so we got 60 grams of this chromaton 10% concentration cream. We want to lower that down to a final concentration of 7%. So once again, you absolutely could do this with C's and Q's, but let's do it differently. So the first step in the alligation, and the alligation is a visual method. So I'm going to put it up here, but then I want to describe what you want to do. So what you need to do is write this down on your iPads on what you're doing this. Everyone start with the high concentration. So what is the high concentration in the question? 10%. Would you agree? So start by writing 10% and draw it up kind of higher on the sheet, wherever you're drawing it, but 10% directly in one spot. Then we want to go directly below that 10% and give yourself some space and write the low concentration that we're mixing with the 10%. And I want to clarify this. I had some student ask me some questions about this. It says to the 10% we are adding vanicream. So what I need is the percent concentration of the drug, chromaton, in vanicream. So what is the concentration of the drug in vanicream? The diluent, the non-drug containing base, 0%. So if you add water or you add a base that has no drug in it, the concentration of drug in that base is what? 0%. So we have 10% on top, we have 0% directly below that, and put some space between the two. Okay, now to the right of those numbers and in between those, so in the middle between the top number and the bottom number, but to the right of it, go ahead and write your desired concentration. So if we mix it 10% up high and a 0% down low, what do we want is in the middle to the right, and what does the question say we want? 7%, so we write 7. So does it make it look a little bit like a triangle? We're making a triangle shape, if you will, with our numbers. With the high number on top, the low number down on below, and to the right in the middle is our desired concentration. All right, so far so good. Now what do we do with those numbers? Let's start with the 10%, and what we're going to do, write a arrow going from the 10% down to the 7%. It should be going down and to the right. So an arrow from the 10% down to the 7, and making another arrow another arrow going down to where you're even with the 0%. So arrow, arrow, and what goes down here at the end of your arrows is a cross subtraction. And you always subtract the higher number from subtract the lower number from the higher number. So you should always get a positive number. So the higher number in this case is 10. So what is 10 minus 7? 3. Okay. Notice though that this has a percent and this has a percent and that has a percent. So the 10 and the 0 and the 7 were all percents. But with our arrows going down, the number that we cross subtract is no longer a percent. Put the word parts next to it. And I know I don't have it listed on my thing here, but understand these numbers when you cross subtract are parts, not percent. So everyone go from 10 down to 7, down to 3, which is 10 minus 7. Okay? Now let's do the same thing starting with the 0, but going up. So an arrow going up from 0 to 7, and then up again so that it's even with the 10%, but going to the right. So let's cross subtract. So the higher number is 7. What is 7 minus 0? 7. And remember, it's 7 parts, not percent. So we have a 7 here and a 3 there. So far, so good. Do you see the visual aspect of this? You kind of set them up like a triangle, and then you draw your X, if you will, with your arrows. You cross subtract, and you get a number. Okay? Understand that this number 7 goes with the 10%. That's what my arrow is going to cross here mean. 7 parts goes with the 10%. 3 parts goes with the 0%. All right? So my only thing that we need to know, how many parts of 10%? 7 parts. How many 0%? 3 parts. How many parts with the 7%? Our target. Our target has how many parts? So the target goes by just adding these numbers up. So what is 7 plus 3? 10. So that means we have 10 parts of our 7%. The 7% number goes with the sum of the two. So do we now have 3 concentrations? 7%, 0%, and did I say so? 10 and 0 and 7%. We also have 3 parts now. We have 7 parts to go with the 10%, 3 parts to go with the 0%, and 10 parts to go with the 7%. Is everyone okay with this part's going with that value? This part's going with this value. Those parts going with that value. All right? Because now all we're going to do is set up some proportions. We're just going to put those numbers on top of each other. So this is this idea of a table. What goes on the top of the table are the parts, and what goes on the bottom is the quantity we have of that item. So of the vanishing cream, which I say is 0%, which parts related to the 0%? 3. We said 3 parts for the 0%, so I got 3 parts on top. Do we know how much vanishing cream to use? No. That's what we're solving for, so just put X in the bottom. Parts over quantity, PQ, parts quantity, parts over quantity. 3 parts over X grams. I do not know how much of that to use. Well, let's move on to the next thing. For the chromaton cream, how many parts? We said 7 from our cross subtraction. We knew there were 7 parts from that. Do we know how much of that cream we're going to be adding? Yes, we're adding 60 grams. So put 7 parts over 60 grams. And lastly, our last proportion is the final mixture, the 7%. How many parts did we say we were going to get out of that? 10 parts. And do we know how much final mixture we're going to get? No. So put Y, because it's different than this X. Essentially, it's what? It's X plus 60, if you want to understand that. But either way, we just don't know what it is. The trick to doing this, the P's over the Q's, is the fact that they all equal each other. The P over the Q for every single ingredient equals each other. So that's why there are equal signs between each of these. So now that we have that set up, what are we trying to solve for? How many grams of vanishing cream, right? Isn't that this X here? Could we use this information to solve for X? Because I know that 3 over X is equal to 7 over what? 60. There's only one variable there. All I got to do is cross multiply and divide, and I can solve for X. And that's all you need to do. So everyone do that. I'll give you a second. That is kind of the answer to the next section. It's essentially to figure out how many grams of the vanishing cream. If I know my P's over Q's for each ingredient are equal. And once I set that up, I can use any P and Q that I know both for to solve for any other ingredient. And since I know the P's and the Q's for the chromaton, I can use that to solve for the vanishing cream. So again, I had 3 parts over X equals 7 parts over 60. So 3 times 60, cross multiplying, and then divide by the 7, gave me 25.7 grams. And that's the answer. That is the weight of my vanishing cream that I was trying to solve for. Did I have any C's and Q's in that at all? No algebra. There was no algebra to that, essentially, other than this last kind of cross multiply thing. So, what are your thoughts? You like it? Don't like it? All right, I'm going to show you, okay, this on all of this packet here, you guys are not answering me on that, but anyways, on all the packet here, I also ask about this alligation medial method. This is not something on the test, and it's not something you're going to have to do. It's just a way to verify. So I'm just going to show it to you. It's kind of cool. It's a way to kind of check your work in the sense. And really, what it says is that for each ingredient, if you multiply the parts times its concentration, so this is parts times concentration, and you get parts percent, because parts times percent gives you parts percent. So 7 times 10 is 70. 3 times 0%, which is the vanishing cream, gives me 0. Okay. Then if you add up the parts, so again, 7 plus 10 is 3. I'm sorry, 7 plus 3 is 10. I'm losing it. Okay, that gives me 10 parts. And 70 plus 0 is 70 parts percent. Then if you just divide the parts percent by the number of parts so that you can get percent, you can see by doing that, you get 7%. And isn't that what we were trying to do? We were trying to add enough of the 10% with enough of the Vanacream to get what percent? 7%. So this ratio of parts to those concentrations will allow us to do that. So it's kind of a final check. Okay, and I'll do that through the questions, but it's not something I would expect for you to do or remember. All right, so go back to here. What number goes on top? High strength, low strength, desired concentration in the middle, cross diagonally do what? Cross subtract, and it's always the higher number minus the smaller number. And then go P over Q and solve for the one that you need. So I'll give you a second here to try to do this. So let me read you the next question. It is similar. In the previous question, we added a diluent to dilute a higher concentration down. Now what we're doing is it wants to know how many grams of diphenhydramine pure drug powder must be added to 30 grams of a 2% cream to raise its concentration to 5%. So instead of diluting from 10% down to 7, we are concentrating, we are fortifying from 5% or from 2% up to 5%. So the only trick to this question is, what is the concentration of diphenhydramine in pure diphenhydramine powder? 100%. If it's pure powder, that means it's all drug. It's 100% drug. So what you can read that as, I'm adding 100% concentration to a 2% concentration to get a what? A 5% concentration. That's your triangle right there. Start with 100% on top, then 2% on the bottom, and to the right in the middle is your 5%. Go through those steps, cross subtract, set up P's over Q's, parts over quantities, solve for the grams of the diphenhydramine. All right, I'll try to work through this and see how you did. First, I'm showing you my work here for the alligation diagram. How did you do? Where did those numbers come from? Well, I would argue the high strength comes from the words pure drug powder. And we said pure drug powder means what concentration? 100%. Pure, meaning 100% drug. We are adding that to a cream that contains 2% diphenhydramine. So to the 100%, we are adding 2%. Okay? And we're going to mix those together, and what do we want to form? We want to form 5%. So that is a percent, 100%, 2%, so that we can end up with 5%. Okay? The diagram. High number on top over the low number, and to the middle and to the right, we have our desired concentration, 5%. Now what do we do with that? And this is quick math. Let's cross subtract. So going from the top through the middle down to the lower right, crossing from top to bottom to the right, 100 minus 5 equals 95. And you'll notice there's no more percent after that. That represents parts. Okay? Now, starting from the lower left, going up to the right, through the middle, going from the bottom up, 5 minus 2 is 3. So do you see where those numbers came from? They come from subtracting diagonally, okay? And always the higher number minus the lower number. Make it easy. And then understand, when we've done it this way visually, this value goes straight across to that concentration. So we need 3 parts of the 100%. We need 95 parts of the 2%. And then the last thing I need to know is how many parts of the 5%, and that comes by adding the 2 parts together. So 3 plus 95 is 98. So 98 parts is the 5%. Okay, so 3 parts, 95 parts, total of 98 parts. Set up P's and Q's, and then solve for what we need to know. So if we start with the diphenhydramine powder, we said that was 3 parts. 95 parts for the cream and 98 parts total. Does everyone see where those numbers came from? I just took that from my alligation. Now just put underneath there the amounts of those. And I would argue we only know one amount. Out of all of that, we only know one amount. But we do know the amount of this cream. So the item with the 95 parts has 30 grams. So the P over the Q, the parts over the Q for the diphenhydramine is 95 parts over 30 grams. Now I could solve for either of the other things that we don't know, but I want to know how much drug powder. So once again, this is what I want to solve for. Let's use that information to solve for essentially the weight or the quantity of the diphenhydramine powder. So 3 times 30 is 90 divided by the 95. So again, just setting up that proportion so you can see it. Cross multiplying 3 times 30 divided by 95 gives me 0.95 grams. And that is the grams. That is the weight of the diphenhydramine powder that I have to add to my 2% cream to mix it all together to get my final concentration to be 5%. Okay? So, question number 1, we added a diluent having 0% concentration to a drug. Question 2, we added pure drug powder, which is 100% to some cream to increase its concentration. Now, well, I'll skip the medial part. Question 3 is what happens when you add a cream with this concentration to a cream with that concentration? So it's neither pure drug nor pure diluent. It's 2 creams that contain a certain concentration of the same drug. So in this case, it's tretinoin for acne. So what are we going to do? We're going to, what weight in the grams of each of the creams? So I want the weight of both that cream and the weight of this cream. How much of both of those do I need to mix together so that in the end, I get this weight, 80 grams, of this concentration? And again, the concentration, 0.04% in this case, has to be somewhere above the low concentration, but below, golly, I'm losing it. It has to be above the low concentration and below the high concentration. So again, the high concentration is 0.05, the low concentration is 0.025, and we want something in the middle. In this case, 0.04% concentration. We said in this alligation, we start with the high concentration. So there on top, did you write 0.05 on top? 0.05 up here. Then the low concentration was 0.025. That's on the bottom. So 0.05 on top, 0.025 on the bottom. Okay. Then in the middle here, to the right, what we want. What is the target? 0.04. Okay. Now let's cross subtract. Starting from the top, are at 0.05, going down through the middle to the lower right. What is 0.05 minus 0.04? I got 0.01. So that's where that number comes from, going this direction down. Now, going from the bottom, going up to the right. So what is 0.04 minus 0.025 going up to the top? I got 0.015. Just cross subtraction in the right order here, in the right direction. Now I know that's the parts for my high concentration. This is the parts for my low concentration. And simply add the 2 up to get the parts for my desired concentration. So what I want in the middle is the sum of the 2. So I add those 2 together, and there's my parts. So I've got my P's. Let's just set them over my Q's. And I only know one Q. So in the end, what am I going to have? I'm going to have the parts of my desired concentration, 0.025. Remember, we got that by cross subtracting or by adding those together. Then the total, the 0.025, the total is my concentration of my parts for my desired concentration. And I know I need 80 grams of that. So I set the P's over the Q's, and I don't know the Q's for either one of my 2 ingredients, but all I need to do is use this proportion equal to that proportion and set this proportion also equal to that proportion. So do 2 separate equations or 2 separate solvings, and I'll know the weight of both of those. All right? So let's see. The first thing I did was start to find the high concentration. For the 0.05, it was 0.015 parts over X equals 0.025 parts over 80. Solve for that by cross multiplying 80 times 0.015, divide by 0.025, and I got 48 grams. All right? So that's my weight. That's the weight of this cream. Now I need to solve the weight of this cream. There's two ways you can do it. Can you guys tell me now, how can we solve the weight of the other cream? Could we do exactly the same math right here using its parts? Absolutely. Could we also say, hey, wait a minute. There's 80 grams total. And if 48 of that is going to be the first cream, the high strength cream, what does the low strength cream have to be? The difference. Would you agree you can just subtract them? I want to make sure it works, but set up the thing. So again, you can still do the 0.01 parts over y in this example is equal to the 0.025 over 80. And you solve and you get 32 grams. So that's certainly the way you can do that one as well. But it should make sense that if we want a total of 80 and 48 grams is going to come from the 0.05%, then clearly I need to get 32 grams from my low concentration, the 0.025%. Okay? This is every possible question I can give you. I could give you a diluent at 0%, I could give you a pure drug at 100%, or I could give you just two concentrations somewhere in the middle, all right? You add them together and get something in the middle of that. The questions all solve the same way. It's just a matter of setting them up, all right? So now, how can I possibly make it more difficult on the exam? Because you know me. The only thing that will be more difficult on the exam is that I won't always give you all of your drug concentrations as a what? Percent. So the only additional step you might have to do for me on an exam is take one of the drug's concentration and convert it from what I give you into a percent before you then just do exactly what we did. So in this question, and I'll give you a little bit of time as well to solve for number 4, it says, what volume in milliliters of gentamicin 40 milligrams per mil injection should be added to a 5 ml bottle of gentamicin 0.3% solution to make a final concentration of 1%. So this is our desired concentration. Here is one of our concentrations. I'll go ahead and say it's the low concentration. So all I need to find is my high concentration, but it needs to be in percents. So the only pre-step to this is to express the weight of the concentration of the gentamicin injectable solution as a percent concentration. Then solve it using the exact same method we've been doing for the other ones, all right? So I'll give you some time for that. In a little bit, I'll show you what my percent concentration of gentamicin is, because you need that to be able to go in that. So really, set up 40 milligrams over milliliter. What are the units of a percent concentration now? Grams per what? 100 milliliters. So you need to go from 40 milligrams per milliliter to some number in grams per 100 milliliters. So you got to convert your grams and you got to convert your volume to 100 milliliters. And that would be your numeric value as a percent weight per volume concentration. That's all what we're doing here in step 1. So see if you can do that. Does everyone see my work for this first step? So again, before we can move on to the alligation, we've got to get all of our concentrations as a percent. So 40 milligrams over 1 mil, and here all I did was convert milligrams to grams. So let's divide by 1,000 to convert milligrams to grams. So 40 divided by 1,000 is 0.04. Now I'm in grams per mil, so just set that up as a ratio there, 0.04 grams per mil. But remember, percent is grams per 100 mils. So set that equal to x over 100 mils, and I solve for x, and I get 4 grams. That means 4 grams over 100 mils, that's 4% weight per volume. Now that we've done that, here is your high strength. Here is your low strength. Here is your target strength. And remember, we are solving for the volume or the quantity of the 4%. So that's the Q we're solving for, is whatever parts of the 4% you get. So set up 4 on the top, 0.03 on the bottom, and then 1% in the middle to the right. Cross, subtract, get your parts, set them over your Q, and solve. How'd you do on your alligation diagram? Is this what yours look like? Let me be honest with you. Do you see where all of these numbers come from? We got the high concentration over the low concentration, the desired concentration on the right. These are all in percents now, so this works. You could not put 40 milligrams per mil in the middle. Everything has to have the same unit. So we got percents everywhere. We cross subtract. 4 minus 1 going down gives me 3. And going up, 1 minus 0.3 gives me 0.7 parts of the high concentration. 3 parts of the low concentration. And remember to add those together to get the parts for your desired concentration. So my 1%, I got 3.7 parts. So in the end, I've got my 3 sets of parts. I only have one quantity, so let's put our P's over the Q's. So the one quantity I know is the 0.3% ophthalmic solution. Its parts were 3, and its quantity is 5 milliliters. So I can set that equal to anything else that I want to solve for. So since I want to solve for the concentrate, or the volume rather, the quantity of my gentamicin ophthalmic, I'll set up that proportion. So if I cross multiply 5 times 0.7, divided by 3, which is what I'll show you on that work here, I got 1.2 milliliters. That is the quantity, in the end, the volume of the injectable solution that when mixed with 5 milliliters of a 0.3% concentration, mix it all up, my final concentration would be 1%. My final volume would obviously be 6.2 milliliters. Okay? Happy smiling. This is good. This is easy. This is so much easier than C's and Q's. Where are my artists? Where are my poets? Are you happy? And the right side of the brain, man, it's just visual. You just kind of line them all up and just set them up and you're done. No C's, no Q's, all right? So let's keep going. As I said, the only way on the exam, especially the unit exam, that I will make things hard, and I will do these kind of things, is again, I said the concentrations I give you to start with may not be in percents. So here's, as evil as they come, I'm giving you what volume of hemp oil, so here's, for the hemp oil, we want at 250 parts per million. My concentration is in parts per million. What volume of that should be mixed with 15 milliliters of a CBD oil containing 25 milligrams per mil, such that in the end we get a 0.2% concentration. Oh my goodness, I've given you 3 different concentrations: parts per million, milligrams per mil, and percent, okay? In the end, you can, so my math people here, you could convert these to any one of those, okay? This works fine in any units so long as they are all in the same units. But trust me on this, as you guys are learning it, convert everything to a percent. Convert things to a percent. That's my recommendation to you. So in this case, let's start by converting 250 parts per million to a percent. Then let's change 25 milligrams per mil, just like we did in the previous question, to a percent. Then we will have a high percent, a low percent, and a target percent. And then the alligation works exactly the same way we've been doing it. So for the first step here, 250 parts per million. That means 250 grams, because we're talking about a weight per volume, parts per million, so 250 grams per 1 million milliliters. I know that seems like a big number, but that's parts per million. 250 grams per 1 million milliliters is equal to, since we want a percent concentration, we want to know how many grams per 100 milliliters. So if we take 250 times 100 divided by a million, I get 0.025%. Okay, so there's my first percent. There's my low concentration. So let's figure out what is the concentration there. So I'll give you another minute there. How do you convert 25 milligrams over mil, convert milligrams to grams, convert mils to 100 mils. 25 milligrams converted to grams, we have to divide it by 1,000. So 25 divided by 1,000 is 0.025 grams. That was per milliliter though. So if we set that equal to some unknown number over 100 milliliters, solve for x, we get 2.5, and that would be 2.5 grams per 100 milliliters, or 2.5%. So now I have a high concentration. We just solved for a low concentration, and there's my desired concentration. Since you guys look beat down already, I'll just kind of keep going here. Let's see how you did. Once we found the concentrations all as a percent, then let's put the high one on top, 2.5 up here, 0.025 down low. And our goal or our target is 0.2%. So we've got our little triangle here, like that. So we cross subtract going down, and 2.5 minus 0.2 is 2.3 parts. Cross subtract going up is 0.2 minus 0.025 gives me 0.175. Those are the parts for the hemp oil, high concentration. The 2.3 are the parts for the CBD oil, And the parts that I want for my final target is the sum of the two. So 2.3 plus 0.175 is 2.475. And just as a reminder, we need to know at least one quantity. So what is the only quantity we know? We know we're going to combine it with 15 milliliters of the CBD oil. So we know the 15 milliliters, that quantity goes with the 2.3 parts. So 2.3 parts over 15 milliliters. Set that equal to whatever we want to solve for. So in this sense, here's my parts over my quantity and the parts for the other two ingredients there. And since we want to know the volume of the hemp oil, this is what we are solving for here. So I would set that up as a proportion and simply take 15 times 2.3 divided by 0.175. That would solve for X, and X would be the volume of the hemp oil. If I do that, I got 197 milliliters. Okay. Any questions on that? All right, we are down to the last one, which is a little weird because we've been doing everything by percent concentration. I still will tell you on the exam, for the most part, whenever you have a drug concentration, use them as a percent. The trick, they all have to be the same. But it turns out you can use this same format as long as all of the units are the same. If each of the numbers in your allegation have the same unit. So in this case, we are going to do that using specific gravity. So this one's a little bit weird. It says a nascent soap emulsion forms when mixing olive oil with calcium hydroxide, which is known as lime water. So lime water and olive oil, you mix those together and you shake them up really good. One's an oil and one's a water. Do oil and water mix? Not by themselves, but what can you add to oil and water to make them mix? An emulsifier. So the problem is the calcium in the calcium hydroxide reacts with the oleic acid in olive oil, forming calcium oleate, which is a natural emulsifier. So with this special combo, olive oil and lime water, you shake it up and it forms a nice emulsion, okay, because of that formulated emulsifier. All right, so this is the reaction I'm talking about. So my question here is what volume in milliliters of the olive oil and the lime water? So I want two volumes. I want to know the volume of the both ingredients that I need to mix together to get what? To get 140 milliliters. So there's my final quantity. My final total mixture will be a total of 140 mils. And I want of this emulsion. But what do I know about this emulsion? That it has a specific gravity of 1.58. That's the specific gravity of my final combination, and I'm going to get that by combining olive oil with a low specific gravity of 0.91 and lime water with a high specific gravity of 2.24. So do you see where these three things are not concentrations, but they are all in the same units. They are all specific gravity. So we can use the alligation exactly the same way. So I'll just show you that for the sake of time. So understand, I put my high specific gravity here, my low specific gravity on the bottom, and my target specific gravity in the middle. So this is the same alligation format that we've been doing for all of these drug concentrations. High over low, desired in the middle to the right. Okay, cross subtract exactly the same way. So 2 minus 2.24 minus 1.58 going down diagonally gives me a difference of 0.66. And again, that goes down low. Going and cross subtracting going up, 1.58 minus 0.91 is 0.67. And so this is the parts for the lime water that has a specific gravity of 2.24. This is the parts for the olive oil, which has a specific gravity of 0.91. And my final emulsion mixture is going to have a total of 1.33 parts, which is the sum of those two. All right. And remember, we want to know the quantities of each of these. And the one quantity I know is the 140 milliliters, which goes with the final emulsion. So if I set that table up, my 1.33 has the 140 mils. That is the quantity of the final mixture, which had a total parts of 1.33. Here are my parts over my unknown quantities for the two. So I'm going to do two sets of equations, one that matches it up with this, and I'm going to take this and do that one as well and set those proportions up. So if I start with the olive oil, just to make life easy, the 0.66 over X is equal to 1.33 over 140. cross multiply, divide by 1.33, and I get 69 milliliters. And this is where it gets hard to remember of what? It's the 69 milliliters of the 0.91 specific gravity, which was the olive oil. So again, 69 milliliters of olive oil. We can do the same thing for the lime water and set up this proportion using its parts, 0.67, and solve for this, or we can say that we're gonna have 140 total, and if I just solve for 69 milliliters of olive oil, then the difference in volume between those two is gonna be the volume of the lime water. So 140 total minus 69 gives me 71 mils of this specific gravity, which was the lime water.